All right, let's dive right in. Today, we're going on a journey deep inside our own bodies to talk about our bones. And let me tell you, they are so much more than just a dry, static scaffold. We're about to discover a dynamic, living system that is constantly working, constantly changing.
So, just for a second, think about it. Besides just holding you upright so you're not a puddle on the floor, what are your bones actually doing right now? The answer? Way more than you probably imagine.
You know, your skeleton is a multitasking marvel. It's got at least 5 critical jobs running all at once. First, obviously, it's providing support. It's also a storage bank for crucial minerals like calcium. It's a factory, producing our red blood cells. It's a bodyguard, protecting our most vital organs. And it's a machine, acting as a system of levers that lets us move. It's an incredibly busy system.
Okay, so let's get to the main idea for today. We have to start thinking about bone not as just some hard, dead material, but as a living tissue that's constantly on the job.
The real magic of our bones is this incredible double act. Yeah, they have that hardness we all know, but they're also unbelievably dynamic. So what does that actually mean? It means your bones are constantly, in very subtle ways, changing their shape to handle the stress of your day-to-day life. It's basically an intelligent, adaptable material.
Now, to really wrap your head around this framework, it helps to see how it's all organized. And it's best to think of your skeleton not as one giant pile of bones, but as 2 distinct, specialized divisions that work together.
This slide really breaks down the body's master plan perfectly. On one side, you've got the axial skeleton. Just think of this as the central pillar of your body, your skull, your vertebrae, your ribs. And on the other side is the appendicular skeleton. The key word there is appendages. These are all the parts that hang off the central axis. Your arms, your legs, your shoulders. You know, the parts that let you move around and interact with the world?
All right, let's zoom way in. We're going to look at the architecture of a single bone to really see how this works. And we'll start with a long bone, something like the femur in your thigh, which is just perfectly engineered for movement.
So every long bone has this main central shaft, right? This hollow, tube-shaped part is called the diaphysis. You can think of it as the main structural beam of the bone. It's where the real strength and length come from.
Then, at each end of that shaft, you find the epiphyses. These are the parts that connect to other bones, and they're what form our joints. And see how they're covered in that smooth, slippery layer? That's cartilage, and it's what allows your joints to move freely without painful grinding. It's a fantastic design.
Okay, so that's the outside, but I mentioned that the main shaft, the diaphysis, is hollow. So why? What's going on inside that space? Is it just empty?
Well, that space is called the medullary cavity. And no, it is definitely not empty. In an adult, this cavity is filled with yellow bone marrow. It's a really key part of the whole internal world of the bone.
Let's keep that journey going inward and look at the actual layers that make up the bone tissue itself. This is where you can really see how it's a living, breathing part of your body.
So what makes a bone a living thing? It's this whole layered system. You've got the super dense, compact bone on the outside for strength. Inside, there's a network of spongy bone, which is where red marrow makes our blood cells. But the real action is in the linings. The periosteum on the outside is what our muscles anchor to, and the endosteum on the inside is packed with cells that are constantly repairing and remodeling the bone your entire life.
Now, not all bones are built for movement. Some are designed for pure protection. So let's look at a totally different and honestly genius design, flat bones, like the ones that make up your skull.
The absolute best way to think about a flat bone is as a protective sandwich. Seriously, it's not one solid piece, it's a layered structure that's built for maximum impact resistance. So here's how you make this sandwich. You start with a slice of hard, compact bone for the top layer. Then, for the filling, you put in a shock-absorbing layer of spongy bone. And for the bottom slice, you guessed it, another layer of hard, compact bone. It's an incredibly clever and effective design.
And here's why that matters so much. If you take a hard knock to the head, that outer layer of bone might fracture. But that spongy middle layer acts like a cushion. It absorbs and spreads out the force of the impact. This often means the inner layer of bone stays completely intact, protecting your brain. It is literally a natural helmet.
And that brings us right back to where we started. Whether we're talking about a long bone adapting to the stress of you going for a run, or a flat bone designed to absorb an impact, the core idea is exactly the same. Bone is not a static object. It's a living, dynamic tissue that is always adjusting.
In fact, your skeleton is so dynamic that it completely remodels and rebuilds itself over several years.
So the next time you look in the mirror, just remember that the very framework holding you together is alive, it's intelligent, and it is constantly changing. Kind of makes you wonder, right? If your very bones are rebuilding themselves, who will you be in 7 years?